Once you got a spot, you gotta stick to it, because it moves in either direction. Yes! The first one!
That was our 3-pole motor prototype, finally working after weeks of effort.
But we need to show you how we got there. Simply put, we wanted to make an educational tool that allows IGCSE physics students to better visualize the concept of electromagnetism.
As physics students, we know how difficult it can be to try and visualize such phenomena. A working visual aid like this can make it much easier to understand. With all the components in front of them, they can alter the different features and see their effect in real life.
This was our third attempt at this project. Our last 2 attempts worked well, however those motors were not very reproducible as the parts required can be difficult to find. This time we took a more modular approach and broke everything down into sections for assembly.
Both of us designed parts that could be 3D printed for use of the motor. This means we could easily share the STL files with anyone who wishes to recreate it.
In order to design our parts, we had to take precise measurements of fasteners and other tools that we were going to use in order to assemble the motor. It took us a while to get the proportions and sizing right for printing, but the end result were reliable and durable parts that were very easy to assemble. We started with sketches before moving over to Onshape and online CAD software to reproduce the models. It took us a long time.
In order to design the rotor, we had to make a coiling diagram to understand where the connection points needed to be. We then designed the part and began testing. After testing, we realized that we had to extend the prongs and deepen the canals so that more wire could be fed through the part. We used this iterative design process for all of our parts.
Once all of the parts were perfected and printed, it was time for us to begin assembling the motor. We began by using superglue as our adhesive to conjoin the rotor to the shaft. We didn't need to use a super strong adhesive as once coiled, the copper wiring would hold everything together.
We ensured to check for continuity on the connection point before moving on to the next coil. In order to check for continuity, we used sandpaper to remove the varnish on the copper wire and then verified with a multimeter. The commutator was made using a copper tube. We used a coping saw in order to cut 3 equally sized segments. Since copper is malleable, we used a battery that had the same diameter as our commutator holder and the vise in order to bend and shape the pieces into cohesive, rounded parts.
Then, using a drill bit, we drilled out holes in the pieces through which the wire would be fed through. We then soldered the wire and commutator together to ensure there would be a reliable connection. Once the commutator was connected to the wire, we placed the pieces on the commutator holder and used epoxy resin to hold them in place.
After one final continuity check, all that was left to do was to pass a current through the motor and hopefully watch it spin.
We used a stripped piece of wire as our brush, as we learned with our past iterations that while carbon brushes are more conductive, they have a very high resistance that makes it difficult for the motor to self-start. The drawback of using a stripped wire was the fact that the commutators became oxidized over time and needed to be sanded in order for it to be conductive again.
Throughout this whole project, we learned the importance of organization and scheduling. We kept track of all of our tasks and made a very simple timeline. Communication was extremely important, as there were some days that we weren't together in the lab. We never fathomed that seeing a motor spin would bring us such joy, but it was a reminder to us that hard work does result in success.
Having to overcome all of those hurdles in the process taught us a lot about perseverance, and both of us came out of this with a lot more grit.
We also became more creative, because sometimes the solution was hiding away, and we had to try something new to find it. Both of us couldn't be more excited about our future as engineers, as we've caught a tiny glimpse of what it means to be one.
We couldn't thank Mr. Thomas enough for pushing us through this project.
Not only did he give us advice about the project, He also helped us make connections and meet other engineers to gain a lot more insight into the world of engineering.